Hello, Dr. Yakub. My name is Rishikeshan. Today I will be presenting to you question 1 and question 2 for the assignment 1. First of all, who is Bono and what problem is he having? Bono is a good friend of mine and currently I'm his personal trainer. His problem is he is dangerously overhelped, so he came to me asking for my help. Therefore, my main objective is to help him to reduce weight and become a healthy person. But before we help Bono, we need to gather his personal information such as age, sleeping habits, sex, weight, height, and occupation. Why is age? Because age can help us to determine the health risk, exercise interval, and the intensity for the client. Second is the sleeping habits, because poor sleeping habits can diminish recovery effectiveness, bring down growth hormone release, and can make mental weariness and failure to focus. And the third one would be gender, because gender also is a consideration in determining the health risk. Fourth is the weight. Weight is the primary goal that needed to be established. Fifth is the height, a factor to determine client's goal based on the standard BMI height and weight. And the last one will be occupation, because by knowing client's work type and routine, we can advise on client's total calorie intakes per day, meal time, exercise schedule, and lifestyle change recommendation if needed. After we have gathered all this information, we can provide Bono an exercise plan and an exercise and diet plan. This is an 8-week program whereby we will keep track of his training routine and result. We will measure the body measurement every week to determine whether the program is a success or a failure. But the most important thing here is how are we going to measure Bono's performance based on the data we have collected. In order to do so, first we need to talk about the static and dynamic data. Static data is something that doesn't change. We can consider this type of data to be a set of fixed data. Since this is an 8-week program that is created in order for Bono to lose his weight and become healthy, we have gathered several data from Bono and suggested a proper diet and exercise plan based on the data we have gathered from him. Upon gathering this data from Bono, there's 3 types of static data we have collected from him, which is age, sex, and height. These data are static because whether Bono performed well or poorly in the program, it won't have any impact on them. Example, if Bono was performing very well on the program, his age won't increase or decrease in matter of 8 weeks, or have a sudden change in his gender, and certainly he won't get any taller or shorter. Therefore, all these 3 data are a set of fixed data that can't be changed. Dynamic data is something that can be changed and continually updated. There are currently 5 types of data that can be considered as a dynamic data based on the information we have collected from Bono, which is the weight, sleeping habits, occupation, type of workout, and food intake. Weight is the main data or can be considered as Bono's goal. This data will change accordingly to Bono's performance. If Bono were to perform well in the exercise and diet plan, he will have lost his weight, else he will gain more or remain at the same weight. Occupation data is the key element in determining Bono's diet and exercise plan. Because let's assume Bono's work type is a desk job. Therefore, the diet plan for his total intake of food calories won't be high because his work type doesn't require high energy and his exercise plan will be more intense. But if he was a laborer at a construction site, then the diet plan will be different. He will need more calories in his food intake to perform heavy duty job, and the exercise plan will be mild compared to desk jobs exercise plan. Among 5 the data that I have mentioned earlier, these 3 data, which is sleeping habits, type of workout, and food intakes, is the data that is needed to measure Bono's performance. The first one is sleeping habits. If Bono doesn't sleep well, this will directly affect his performance because without getting proper sleep at night, the muscle won't be able to build and repair during the sleep, resulting the next day to have muscle soreness and unable to continue with the exercise plan. Besides that, poor sleeping habits will also lead to craving and diet choice will falter, which may lead him to take sugary snacks or food that is not listed in the diet plans, thus making him to gain weight or perform poorly. Second will be the type of workout. This is one of the key elements in reducing Bono's weight because different type of workout will give different kind of benefit. As Bono is a dangerously overweight person and also a starter, then the best recommended choice workout plan for him is aerobic exercise, such as swimming, cycling, jogging, and etc. This type of workout will help to improve Bono's overall fitness, thus helping him to build endurance, which make it easier to carry out his everyday activity. And the last one will be food intake. This is the most important of them all. If Bono is able to control his food intake and follows the diet plan we recommended, he will be starting to lose his weight because reducing the amount of calories intake per day will help to lose weight. Let's assume day 1 Bono was following his workout plan and diet plan perfectly, but at night he was busy watching his favorite TV show and neglected his sleep. Therefore, this will indirectly have an impact on day 2 performance. Due to lack of sleep, Bono won't be able to recover from his workout and won't be able to carry out his day 2 workout as planned. Besides that, he may even didn't follow the diet plan due to brain's inability to make healthy food choices. Even if he sleeps well on day 2, the performance of day 2 has already been messed up, thus making him harder to achieve his main goal, which is the loss of weight. Well, that's all for my part. Thank you for listening. And now my fellow teammates will carry on for question 3 and question 4. Thank you.
The initial objective measurement designed for Bono might not hold true, so additional type of data needs to be collected. For example, mass, weight, height, BMI, exercise, sleeping routine, diet plan, caffeine intake, water intake, cholesterol intakes. These are all the examples of static, dynamic, categorical, and numerical data. So I'll tell you how to collect the data and what we can do with it. So mass, the device used to measure mass can be mass balance taken every 3 days and it can be collected on data app and stored in it. Weight, how to measure it. Multiply the mass that you recorded with 10 or 9.81 for more accurate results. Moving on, height. Stadiometers is used for measurement of the height, which you can store and record on the app. BMI, it is an attempt to quantify the amount of tissues, mass, muscles, and etc. It is also known as body mass index. You can measure the BMI by dividing the mass with the square of the height. You can store the data on the app and compare with the following values from which you can know if you are an underweight, normal weight, overweight, or an obese. Then, moving on to exercise, you can record the type of exercise the person does, duration of the exercise, frequency of the exercise, and that data can be recorded on the app. And then, sleeping routine, number of hours slept per day, that is needed to be calculated. Then, sleeping time, like for example, does the person sleeps during the day or the night, and sleeping routine recorded on the app accurately. Diet plan. In diet plan, it covers almost everything such as type of foods you eat, eating time, the amount of food, the utensils used. It is actually the size of utensils. It's like a small pot or a big frying pan. Then the oils used and the junk food you eat. Caffeine intake. Types of drinks taken in which all the caffeine is there. Number of time of drinks like tea or coffee are taken per day. And that data is stored on the app. Water intake, the number of glasses of water per day, that is to be calculated. And other than that, cholesterol, the type of oils you used, and the type of meats eaten containing different levels of cholesterol. Lastly, heart rate. Measure it using built-in scanner in some smartphones and automatically recorded on the app used. And you can record it after every few hours. One of the most excruciating pain points during data exploration and preparation stage of an analytics project are missing values. Let's look at some techniques to treat the missing values. Deletion. Unless the nature of missing data is missing completely at random, the best avoidable method in many cases is deletion. Let's take the first example. List-wise deletion. In this case, rows containing missing variables are deleted. But before you just assume that list-wide deletion is an adequate approach, it is important to establish that these two conditions are met. First, the data are missing completely at random. Secondly, you have sufficient power anyway, even though you lost a part of your dataset. Moving on to pairwise deletion. In this case, only the missing observations are ignored and analysis is done on variables present. Both the above methods suffer from loss of information. List-wise deletion suffers the maximum information loss compared to pairwise deletion. But the problem with pairwise deletion is that even though it takes available cases, one can't compare analysis because the sample is different every time. So moving on to the third one, popular averaging techniques. Mean, median, and mode are the most popular averaging techniques, which are used to infer missing values. For example, it is a random example of a revenue. You might assign the average defined by mean, median, or mode to such missing value that you are inferring missing value for a revenue. You could also consider taking into account some other variables such as gender of user and or device OS to calculate such an average to be assigned to the missing values. You can get quick estimate of missing values, but this may affect the statistical analysis of dataset as percentage of missing observation imputed may get affected. So moving on to the last one, multiple imputation. It is currently the most popular approach. In this software creates a plausible values which is based on correlation for missing data. It averages stimulated data sets by incorporating random errors in your prediction. Missing data is like medical concern. Ignoring it doesn't make it go away. Ideally, data is missing at random, and one of these approaches will help you to make the most of the data that you have. Thank you.
Hello, good afternoon everybody and welcome to question number 5 and 6 of section 2, assignment 1. My name is Arsalan Navid Anwar and I'll be talking about recommending appropriate analytic techniques to answer specific business questions. Now our question number 5 focuses on contrasting 6 different analytic techniques and comparing them based on typical utilization, strengths, weaknesses, and techniques that we have at the moment are statistics, database queuing, data warehousing, regression analysis, and data mining. Now, let's focus on statistics. Statistics, on the first hand, is actually collecting and exploring and presenting large amount of data. So now, as you can see in the picture, we have two kinds of statistics. One is normal statistics and one is machine learning. Traditional statistics includes a lot of numerical work like demographics. It's using demographics, forecasting, business and stuff. And machine learning, on the other hand, is actually an artificial intelligence system in which the system itself learns from its surrounding. It's applied in everyday research, industry, and government, and it actually is used for professional, or how do you say, professional decision making, used in statistical programming, econometrics, statistical quality improvement, and much more. Now, traditional statistics versus machine learning. Traditional statistics is actually subfield of mathematics dealing with finding a relationship between variables to predict an outcome, whereas machine learning is an artificial intelligence system dealing with building systems that learn from data instead of explicitly programmed instructions. Now, traditional statistics on one hand, focus on analyzing and summarizing data. The problem with traditional statistics is that it's actually conservative in nature. It's not open up. It doesn't look at all the aspects, not focuses on the major facts or major focuses of the data. Machine learning, on the other hand, focuses on learning from all sorts of data and is more liberal in techniques and approaches, which means that more data it can analyze more data and can be much better in understanding. Now we're focusing on the strengths and weaknesses. Machine learning is pretty good. The feature learning, the parameter optimization, the system is machine learning system can learn from itself. You don't have to do much of the work. However, the problem with the weakness, on the other hand, is that it's limited. It's not guaranteed that the machine learning algorithm will work always in every single case, because it's still machine learning. It still needs assistance from human hands, so it cannot adapt to new situations. It still needs some kind of assistance from human beings, and you need a large set of data. But if you're working on a small set of data, then your data won't be accurate. Machine learning benefits when you have a huge amount of data, and you can actually churn that, or you can break that data into a more resourceful way. Traditional statistics now is a basic study of concept and is a cornerstone of many engineering and science fields. It can be used in numerous fields and has actually been used and is still being used. But the weakness is that it's actually conservative in its approaches and you cannot use it for every single process. It's time consuming, and what you can achieve from machine learning in few minutes might take you hours or days just if you use traditional statistics. On the other hand, let's move to data queuing. Data queuing is the process of asking questions of data in search of specific answer. Queries are actually normally structured and require specific parameters and a special language called structured query language. Now the problem here is that the query must be written in the language that the database requires. It's used to understand how many items were sold in the region in the last 2 months. The strength of database queuing is that it allows you to immediately insert, update, delete, or retrieve data with simple commands. It's easy to learn, and most of the commands are simple sense. However, the weakness, on the other hand, is that if there are cross-database queries, you cannot access it, even though you might have the same username and password. Thus, it is not an easy way to share data. And connection strings must specify the contained database in the correct connection string. So if you cannot develop a connection, then you cannot move forward or understand or link the data. Data warehousing now is actually designed to give a long range view of data over time. And as you can see from the picture, it's actually a place where data is stored. It aggregates data instead of just, it focuses the data in a big warehouse so that when needed, the data can be used at any single time. Now, it's actually stored on a cloud system, so where most of the company employees can access the data and use the information. And when they use it, they can actually store on the data so that the data is achievable. It's actually can be used by most of the employees. The problem with the strengths of data warehousing is that it's an easy integration and it adds value to the CRM, as over here shows customer relationship management system, and it helps you to identify errors before actually updating the data, so you can actually eliminate any errors and your report will be perfect. However, it's time consuming because the data warehouse performs many other functions, so you have to input raw data by yourself. And the problem is that most businesses or managers do not understand the full potential of the data warehouse, thus they cannot fully use it or exploit it to their benefit. Regression analysis, on one hand, is a predictive modeling technique investigating relationship between a dependent target and independent variable. As shown in the picture over here, it fits a line to this messy scatter plot. X is called the independent variable or predictable variable, and Y is a dependent or responsive variable. The regression analysis of prediction line has the form y is equal to a plus bx. Now, there are three things that make the regression proper regression analysis: the number of independent variables, shape of the regression line, and the type of dependent variable. It's used to find causal effect relationship between two variables. For example, the BMI matrix is actually a good example of regression analysis. It's to find out that if a person weighs 80 kilos, then how much of a height he should have. Of a person whose height is around, let's say, 160, 180 centimeters, how much weight should he have? So BMI is a good example of regression analysis. Now, I couldn't find any strengths, but the weakness for it is that it only looks at the linear relationship between dependent and independent variable, and looks between the mean of the dependent variable. They cannot discuss much about that. Now, let's proceed to data mining. Data mining is a process of sorting large data sets to identify patterns and establish relationships, and through data analysis. Now, most of the time it's used to predict the data, predict the information or forecast. And predictive data mining is the most common type of data mining. As you can see in the picture on the right, you see there are four sections. The first section, you acquire the data over here. You input the data. Second, over here, you clean the data. You form the relationship. You look at the patterns. You identify the patterns. Then in the third one, you actually use the data, and you actually give it a proper format or a model which can be used to forecast or gain the desired outcome that we need. And then at the end, we make the report. Similarly, steps in data mining are as follows: initial exploration, the kind of data to be needed, and from where the data will be gained; model building or pattern identification, validation, and verification, which is really important; and the final stage is deployment. Now, data mining is actually used by companies to turn raw data into useful data, and it's usually used to learn about the customer, develop more effective marketing strategy. Helps in increasing sales and decreasing warehouse. However, effective data mining rests or proceeds upon depends upon effective data collection and warehousing. The more effective data you have, the bigger the warehouse, the more easier it is. One example of data mining tool that most businesses, which is really popular these days, is Google Analytics. Now, the strength of data mining is that it's significant pattern generation. You can actually collection of large data that can create indicative patterns, important factors, and flaw detection. However, the problem is that it is expensive. It requires skilled manpower, time, and other complexities. And more importantly, the privacy issues, because you're selling your customer's data to a third party without their consent, which sometimes creates problems, such as and might not be acceptable to some customers. So now we'll proceed to question number 6, and we will be answering the 4 questions. Who are the most profitable customers? Is there a difference between profitable and average customers? Characteristics differentiating profitable customers from unprofitable ones. And the final and last one will be, will some particular new customers be eventually profitable? So now we can see that for statistics is used for forecasting, but it's not used to find customer. You cannot understand the customer statistics. Database querying is something else. It's used for understanding question. The most two things right now that was significant for the first question are data warehousing and data mining. Data warehousing will contain information such as the customer name, gender, membership card number, the purchase history, and data mining will be used to understand about the customer. So now we use data mining. Now this is where we'll actually use Google Analytics to understand how it actually benefits. So now, as you can see, it shows this is a typical page of a Google Analytics in which you can actually see the average number of page views in each session, which content was viewed most often, how many people actually visited your page, including your new visitors and your old visitors as well. And bounce rate is basically tells you how many people are leaving your website after viewing only a single page, so the lower it is, the better. Average session, how much time people are spending on it, and single visit to website, which means shows what did they do on your website. Did they buy things or not? Did they actually interact? Did they look at the offers or something? And in addition, if the pie chart on the right shows the number of visitors visiting. Thus, data mining, thus Google Analytics is a data mining tool which can be used to predict which customers are profitable or not. And as you can see that Google Analytics is actually used by businesses, shopping, and technology. These three sectors rely on customer trends and forecasting customer demand. Thus, these three sectors use Google Analytics in high ways. Therefore, data mining is a really good tool, or Google Analytics is a really good data mining tool to understand profitable customers. Now, the difference between profitable and average customers. So, what's the difference between them? See, customers who purchase only premium product with highest gross margin, they might be good customers. But then evaluating customers only on sales volume might be misleading. You might have some customers who buy pretty less, but they buy products with highest gross margin. On the other hand, you might have lots of customers who buy products with the lowest gross margin. So you have to see which customer is actually more beneficial, regardless of the volume sales he buys. Now we'll talk about No Service. No Service was actually a firm, and their internet provider firm. What happened was that their services, their people were leaving day by day. Their customers were turning away from them. So they used data mining to understand, to retain their customers, and to know understand which customers will actually stay with the firm, which will actually leave. And they calculate the churn rate. So churn rate is actually where you calculate the number of people who customers who have left your company. You calculate by customers lost divided by total customers. So when they used data mining, they found that their churn rate fell from 8% to 7.5%, and it allowed them to save $1 million per month in customer acquisition costs, which eventually improved customer relationships and dramatically increased their profitability. Now, profitable versus unprofitable customers characteristics. This is how you calculate profitable versus unprofitable customers. Customers purchase gross revenue minus cost of goods or services sold plus the specific additional cost of service. So you have to see if this value is greater than this, then it's a profitable customer. However, if this value is far greater and it comes negative, then that's not a profitable customer. Customer who calls you every day is less profitable than one who pays on time and never calls you. Now, sometimes less profitable customers can still provide tangible benefits like signing long-term contracts, or they might actually act as brand ambassadors, enhancing your business image to association. They might act as brand ambassadors, and they might actually promote your brand in more than one way. So you have to be careful when you look at it. And for the new customers, as you can see, we talk about Big Bang Credit over here, which actually annually conducted 25 direct mail campaigns. Now, as from the data, you can see that they used to mail 1 million people about their credit risk who would like to apply their bank for credit risk and stuff. The cost of mailing was $1, so they actually incurred a cost of $1 million. The number of responses they would get out of 1 million was 10,000, and the gross profit per response was $125. The gross profit overall was 1.2 million, whereas the net profit was 250,000. They had no model what they're using that time. However, the thing is, then the management wasn't really happy with this, so they actually decided to use a model. So they used two different models. They used the predictive model showing who would respond, and they used the neutral net model to show a credit scoring model, which allowed them to understand or identify customers with good credit risk and who were most likely to respond to order. With this model, they only mailed 750,000 people, which means they incurred a cost of $750,000. The number of responses obviously was low, and the gross profit was the same. Since the number of people emailed were less, the response was less, thus their gross profit was less. However, their net profit increased because these people who were responding, they were good with their credit risk and they would pay on time. And even though they incurred a cost of $40,000 on the model, this predictive model, these two models that they used, however, their net profit was still higher, $85,000 high compared to the older system. So there you can see that how data mining can be used to predict your customers' ideology, or you can actually retain your customers, or actually transform your original customers into new customers, to profitable customers. So that's all. Thank you very much for listening. Thank you very much for your time. Hope you enjoyed it. I know my voice wasn't clear, but it's okay. And these are the references. Thank you very much for your time. Good luck.